In continuation to the previous lecture, today we will start immobilized enzymes at work. Sales of immobilized enzymes peaked in 1990 when they accounted for about 20% of all industrial enzymes sales, almost entirely due to the use of glucose isomerase for the production of sweetening agents. Other commercial applications utilize penicillin acylase, fumarase, beta-galactosidase, and amino acid acylase. Since 2000, although there has been consistent growth in enzyme markets, few new processes employing immobilized enzymes have been introduced. The following three examples highlight many of the biochemical, technological, and economic consideration relating to the use of immobilized enzyme on a commercial and industrial scale. First is production of high fructose syrup. The most significant large-scale application of immobilized enzymes involves the production of high fructose corn syrup, HFCS. HFCS means high fructose corn syrup. Although most of the general public believe that sucrose is responsible for the sweetness of food and drinks, there have been significant efforts to replace sucrose with alternative and often cheaper soluble caloric sweetening agents. CFCS means high fructose corn syrup is a soluble sweetener that has been used in many carbonated soft drinks since the 1980s, including brand name colas such as Coca-Cola and Pepsi-Cola. HFCS is produced by the enzymatic digestion of starch derived from corn. Corn is maize. Developments in HFCS production have been most prominent in countries such as the USA, which have a high capacity of produce starch in the form of corn, but which do not cultivate significant amounts of sugar cane and or sugar beet, and must therefore import either the raw products for processing or the refined sugar sucrose itself. Simple corn syrups can be manufactured by breaking down starch derived from corn using the enzyme glycoamylase alone or in combination with alpha amylase. These enzymes are cheap and can be used in a soluble forms since starch has to be extracted from corn at high temperatures because starch has poor solubility at low temperature and forms very viscous solutions. The process utilizes enzymes from thermophilic organisms which have very high temperature optima. Simple corn syrup is therefore composed predominantly of glucose, which unfortunately has only 75% of the sweetness of sucrose. However, in order to make the syrup sweetener, the enzyme glucose isomerase, which catalyzes the following reaction. Glucose in presence of glucose isomerase transform into fructose. This enzyme will produce a roughly 50:50 mixture of glucose and fructose at equilibrium, since fructose has 150% of the sweetness of sucrose. This glucose-fructose mixture will have a similar level of sweetness to sucrose. However, glucose isomerase is an intracellular bacterial enzyme and would be prohibitively expensive to use in the soluble form. Second is hydrolysis of lactose. Within the dairy industry, the production of 1 kilogram of cheese requires about 10 liters of milk and produces about 9 liters of whey as a waste product. Whey is a yellowish liquid containing 6% dry matter or which nearly 80% of lactose. The enzyme lactase beta galactosidase may be used to break down lactose to its constituent monosaccharide, namely glucose and galactose, which are more soluble than lactose and have potential uses as carbon sources in microbial fermentation and can also be used as caloric sweeteners. Lactose is converted into glucose plus galactose in presence of lactase enzyme. Valio Limited of Finland has developed arguably the most successful commercial process for the treatment of whey. Using a lactase enzyme obtained from the aspergillus, immobilized by adsorption and cross-linked onto a support resin, whey syrup are produced that have been utilized as an ingredient in drink, ice cream, and confectionery products. The aspergillus enzyme has an acid pH optimum of 3 to 5, and by operating at low pH, the process avoids excessive microbial contamination. Treatment plants that utilize 600 liters columns have been built in Finland, and these are used to treat 80,000 liters of whey per day. This technology has also been used to produce whey syrup in England by Dairy Crest and in Norway. Similarly, technology can also be used to remove lactose from milk. Lactose-free milk is produced for consumption by those who have lactose intolerance, a genetic condition, and also for consumption by pets such as cats, which are often unable to digest lactose easily. The first industrial processing facility to use immobilized lactase to treat milk was opened in 1975 when Central del Latte of Milan, Italy utilized a batch process in which yeast lactase with a natural pH optimum 6 to 8 was immobilized within hollow permeable fibers. This process was capable of treating 10,000 liters of milk per day and was operated at temperature to prevent microbial contamination.